It's Ms. Hippenmeyer here, and we are working on day 2 of absolute value. Your I can statement is, I can explain absolute value. Recall that absolute value is a number's distance from 0. For example, the absolute value of 4 is 4, since 4 is 4 units from 0. The absolute value of -4 is also 4, since -4 is 4 units from 0. Now we're going to apply our knowledge of absolute value to compare two numbers. And we will either use an inequality symbol or an equal sign to compare them. So let's read the directions. We're going to, number 1, find the absolute value of each number. So if you see bars, if you see the absolute value symbol. Then compare the two values by inserting the symbol that makes the statement true. So either an equal sign, a less than sign, or a greater than sign. So let's complete this first example, and I'll show you what I want you to do. So -5.6, this is the absolute value of -5.6. Well, -5.6 is 5.6 away from 0. Now we're going to take the absolute value of +5.6. Well, +5.6 is also 5.6 away from 0. Basically, absolute value makes the number positive, or if it's already positive, it will stay positive. So these two are equal. Now these number lines are here in case you need them. With this problem, I didn't think we needed it, but if you ever need it, I added a vertical and a horizontal on every one of these problems. All right, look at this next example. All right, the absolute value of 9 is 9, and the absolute value of -18 is 18. And now we compare the two numbers. On the number line, 18 is going to be further to the right, so it's going to be larger. 9 is further to the left or closer to 0, so it's smaller. So we would read this comparison as 9 is less than 18. All right, the next example, we have the absolute value of -13 and 1, well, this goes tenths, hundredths, so 1/100th, and that becomes 13 and 1/100th. And the absolute value of -13 and 1,000th is 13 and 1,000th. Now, I want you to recall the other day, the trick that we use for comparison is to change them so that they're both the same size pieces. So over here, we have three numbers to the right of the decimal. So tenths, hundredths, thousandths. This is 1/1000th. That decimal value represents 1/1000th. And over here, we only have two numbers. So let's add a 0. And now this becomes 10/1000ths instead of 1/100th. And once it's 10/1000th, then we can compare it more easily to 1/1000th. And I hope you realize that 10/1000ths is going to be greater than 1/1000th. So 13 and 10/1000ths is greater than 13 and 1/1000th. All right, now we're comparing the absolute value of 5.75, which is actually 5.75, to -5.8. So we do not take the absolute value of this because there were no bars. These bars mean absolute value. There were no absolute value bars around the -5.8. Now, this should be a simple comparison. A positive number is always going to be greater than a negative number, so we put a greater than symbol in between. Next example, the absolute value of -1/3 is 1/3, and the absolute value of -2/3, well, -2/3 is 2/3 away from 0. And now that we took the absolute value of each, we can compare them. Well, if you think about a number line, I'm going to use the number line over here. If we have 0 here, we could say this is 1/3, this is 2/3, and this would be 3/3 or 1. And 2/3 is higher up on the number line, so it's larger. Or you could say it this way, 1/3 is lower on the number line, so it's smaller. Remember, as you move downwards on a vertical number line, the numbers get smaller and smaller. So 1/3 is less than 2/3. All right, now we're comparing -30 and -54. There's no absolute value symbols. We can just go ahead and compare them. So on the number line, let's go ahead and go to this number line over here. I'm going to place 0 and then we'll put negative 30 about here, and then negative 54 is even further to the left. So how does negative 30 compare to negative 54? So negative 30 compared to negative 54. Well, negative 30 is further to the right. It's closer to 0. And if a number is further to the right than another number, it's larger. So negative 30 is greater than negative 54. It's closer to those positive values. All right, we're comparing negative 2 and 1/8 to negative 2 and 1/7. We don't have any absolute value bars, so we can just leave this as negative 2 and 1/8 and negative 2 and 1/7. If you think about splitting up this pie into 7 pieces and splitting up this pie into 8 pieces, we have to divide this more. So these pieces are going to be smaller pieces. So those are going to be smaller pieces, the 1/8 pieces, and the 1/7 pieces are going to be larger pieces. So now we're comparing them, and we need to put them on a number line. So I'm going to go up here and I'm going to call this 0, and I'm going to say that this is about negative 2 and 1/8, because remember the 1/8 is smaller, so negative 2 and 1/8 is not as far from 0, and then negative 2 and 1/7 is a little bit further from 0. So maybe this would be about here, and this would be just below that. And so if you think about it, negative 2 and 1/8 is closer to 0. It's higher up on the number line, so it is greater than the negative 2 and 1/7. And now it's your turn to complete some work on GoFormative, just like the work that we just completed.